morning, afternoon, or evening, depending on when you watch this. So today we're doing a triangular pyramid, and we're going to look at how we go about finding the volume, surface area, and surface area of a triangular pyramid. So if you look at it, we have a base that is a triangle, obviously, because it's a triangular pyramid. And this triangle is a equilateral triangle in terms of it has 4 units there, it has 4 units there, and it has 4 units there. So something that has a triangle that has all sides equal is called an equilateral triangle. So that's an equilateral triangle, right? The triangle on the face, so if I stand right here, the face that I'll be looking at, that triangle, I'll pull it out, I'll put it here. The base of it is 4 units, right? The base of that triangle is 4 units. The height of that triangle we given here is 16 units, 16.5 units. Right? And what else are we given about the triangle? Nothing else, right? So remember, this one will also have a height. So I'll call this height 1, right? So we asked to solve volume and surface area. So let's start. Volume of a pyramid is all pyramids have the same volume formula. The formula says a third of the area of the base. So this is base area multiplied by the perpendicular height. That's the 15 units that we have there, right? So what is the area of the base? The area of the base is this triangle here. And the formula for that is just half base multiplied by height. I'll call it height 1 because I put height 1 there, right? And the perpendicular height will be capital letter height. So as it seems, we have almost everything in this formula beside that height 1. We need to find that height 1. So how do we find height 1? We just apply Pythagoras. So you apply Pythagoras, right, to solve for that height. If you look at that right angle triangle, I'll put it down here, right? We have height this side, we have 4 units there, and we have 2, because remember, the whole base is 4. But if we take half of it, then we'll have 2 units. Do not forget that. It's very easy to forget and put 4 units there. And once you put 4 units there, it won't make sense. You can't solve that Pythagoras there. So let's apply Pythagoras there. Pythagoras, remember, it says the hypotenuse squared, which is 4 squared, is equal to the side squared, 2 squared, plus the other side squared, which is my h squared, or my h1 squared that I'm looking for, right? Take the 2 to the other side. I have 4 squared minus 2 squared is equals to h1 squared. 4 squared is 16. 2 squared is just 4, right? And if I subtract both of them, I just get 12. h1 is the square root of 12. What is the square root of 12? It's 3.5. 3.5 units. So we have h1 now. We solve for h1. Now we're going to have to use it. Apply it in the volume formula. It's a third, half the base of that triangle, remember, it's this one here, right? It's 4. The height of the triangle, I just found it, is 3.5. The perpendicular height of the pyramid is 15. Right? You just multiply all of this into your calculator. You have a third. 3.5. 15. So this gives us 35 units cubed. So that's how we calculate volume of a triangular pyramid. So now how do we calculate surface area? So surface area, remember what we're doing when we're calculating surface area. We're calculating the area of each face. So let's take that shape. I don't know where we're going to draw it, but I'm going to draw it. Can I erase that and draw it right up there? I want some space to draw my shape. So this is how it's going to look. It's a triangle, another triangle that side, another triangle that side, and another triangle that side. So this is my base triangle, base triangle, and these are the other ones that are standing up. These are the side triangles, side triangle. And one thing to note, since my base triangle is equilateral, that means there's a 4 there and a 4 there and a 4 there, that means these triangles are going to be the same as well, right? So this area of this triangle will be equal to area of that triangle will be equal to area of that triangle, right? So let's write that in my formula here. So we have the area of that one, so it's base area plus 3 times of side area. And when I say side area, I'm talking about the side triangle area. Right, the area of the side triangle. Right? So from here, let me use a better color. Base area is still half base times height. Right? Remember I called it height 1. So let's just put height 1 there. Plus 3 times of half base times slant height. It's this slant height there. So let me call that height 2, so that I can distinguish which height I'm talking about, right? Then you just substitute now. It's a half. The base of the first triangle is the inside triangle, right, which is just 4. The height of that we had calculated was 3.5. 3 of half. This triangle here, the height of it is the 16.4, but the base of it is 4 as well. So the base is the same. That's why I didn't call them different bases, because I know it's the same base, but the height is different. That one is 16.5. Right? You see it? And then you substitute all of this in your calculator. So you have 1 over 2, the first area, the base area, plus 3 of the side areas. And that's 16.5. Oh, so we get my surface area as 106 units squared. As easy as that. So let me just go through it again. Volume Volume is always a third the area of the base multiplied by the height. The base in this case is a triangle, so I put half base times height there. That's the area of my base, with base triangle, and then I multiply with the height. Substitute everything, I get 35 units squared, units cubed. The surface area, on the other hand, I calculate the area of the base, which is this triangle, base triangle. Alright, and then I add it with 3 times of just the area of this side triangles. So when I open it, I showed you it looks like that, right? And you just plug this all into your calculator, you'll get 106 units squared.